Graders, we're in 8.9. We're going to do example 4, a little bit of an application problem, and I do have some information above that's going to help us. We have a formula here that's going to help us down below. Now, h is the height of that object that we want, like if you were trying to shoot something in the air, the height that we're trying to attain for that particular object. V is initial velocity, and velocity is just a strange science term that means speed, if you didn't know that. Velocity is speed in feet per second, and C is the beginning height of the object. So what we have here in example 1, or example A, I guess in example 4, is you have a weight that's a foot above the ground. And it's a carnival strength test, and there's a really neat picture of it in your book if you've never seen one before on page 585. Basically, you've got this weight here, and you're trying to see if you can shoot it straight up and hit the bell here at the top. This would be a bell here, and here's your weight. And then somebody with a sledgehammer is going to try and hit that weight right here and see if you could, actually I guess the weight's right here at the bottom, and you're just trying to see if you can shoot it all the way up to the top, okay? Well, in your book, and you need to know this to help you solve the problem, the top is 20 feet high, and that's the height that we are trying to reach, is that. So when you plug into h equals negative 16t squared plus vt plus c, you actually need to know 3 things: height, velocity, and of course, the beginning height of the object, which is c. So a weight, in this one, it says a weight 1 foot above the ground. So there's your c right there. It's a foot above the ground. On a carnival strength test, it's shot straight up with an initial velocity of 35 feet per second. So where v is, put 35. Okay, and then we can drop down the negative 16t squared. Now the height that we're trying to reach, remember I told you over here, you need this piece of information to solve. The height you're trying to reach is 20 feet. So I want to see if we can make it 20 feet. Okay, with that particular speed of swinging the sledgehammer, if I swung it that fast, 35 feet per second, would it get the little weight all the way up to 20 feet. That's what we're after, okay? So remember, we can't use the discriminant just yet to solve this problem. We have to get 0 by itself on one side. I don't clearly know what C is just yet, so I've got to subtract 20 from each side. 0 has to be on one side. You cannot solve for the discriminant if 0 is not by itself. Okay, now we have enough information. I know what A, B, and C are. A is negative 16, B is 35, C is now negative 19, because I had to move that 20 over. 1 minus 20 is negative 19. So let's go to our discriminant. We got B squared minus 4AC. So B squared, we're going to take 35, and we're going to square that, minus 4 times negative 16 times negative 19. Now take your calculator, I hope you have it handy, you're going to need it, and plug this in carefully. Go ahead and put 35 in parentheses just for the practice. Minus 4 times negative 16 times negative 19. Okay? And we're looking for the discriminant. We want to know what that number is. Go ahead and write it down if you think you know it. I got 9 as my discriminant. Now that information is important because if that number is positive, if your discriminant is positive, yes, that speed will carry the weight to 20 feet. If 9 was negative, we would never meet that 20-foot mark. It's too weak of a swing. So because 9 is positive, we can say, yes, the weight will reach 20 feet. okay? And that's all because of the discriminant. The discriminant can tell you that. Now, in the bottom one, it's the same exact situation, okay? Your height is still 20 feet. That will not change. This time they changed the velocity on you. They said, well, let's slow the hammer speed down a little bit. What if they only swung it at 20 feet per second instead of 35 feet per second? And it's still a foot off the ground. Okay? Use those numbers. Plug into that basic formula. Emulate what I did. Okay? Plug in the numbers, get 0 on one side, and then test the discriminant. With that velocity, will the weight reach 20 feet in height? Okay? This will be your extra credit problem. And I'm going to give a point for that if you can say yes or no, and the reason why. Okay? So good luck with that. Bring your questions to class tomorrow.